Thank you.
Ready?
Yes, sir.
감사합니다.
Thank you for attending our presentation. I'm 재민우, majoring electronic engineering, and it is 효준이 and 유찬이. Have you ever imagined about a computer that acts like human do? We are living in an area where artificial intelligence may revolutionizing in many different parts. It helps us in data analysis, prediction, and automation. However, it also has limitation. It lack of data, and also it has bias and ethical concerns. So to address these limitations, we are now developing organoid intelligence called OI. It is a technology that emphasizes natural balance and mimicking the process of human nervous system. Now we are address 4 contents. First, we compare energy efficiency between AI and OI. Second, we will discuss difference of required data between AI and OI. Third, we explain significance of OI research process. Finally, we will examine market size of OI.
I will present energy efficiency and learning efficiency among the specs mentioned above. First, energy efficiency. One of the critical limitations of AI is its immense energy consumption. Training large AI models require substantial computational power and energy resources, significantly contributing to carbon emissions and posing a challenge for achieving carbon neutrality. In contrast, organoid intelligence are more energy efficient. This table compares the supercomputer frontier, which means AI, and the human brain with using numerical values. For example, the human brain operates at 10 to 20 watts, while the supercomputer frontier consumes about 21 megawatts of power. Organoid intelligence system can mitigate the environmental impact of computing and aid the transition to carbon neutral technology by reducing power requirements. Second, learning efficiency. Artificial intelligence require vast amounts of data and time to train. Conversely, organoid intelligence, which utilize the innate abilities of biological neural networks, show performance for faster learning and low data requirements. These comparative bar graphs show the learning efficiency of OI and AI in playing phone games. The horizontal axis means different types of groups. For example, MCC, mouse cortical cells, and ACC, human cortical cells for OI, and DQ and DeepQ network, A to C, advantage actor critic, and PPO, proximal policy optimizations for AI. And the vertical axis represent key gameplay metrics. The average rally length of pedal hits before missing, and aces means the percentage of missed balls on the initial serve. And the color, the bar graph color means gameplay time. Green means first 5 minutes after the game start, and orange bar means over the next 15 minutes. So in the first 5 minutes in this graph, all groups have average rally length of 1.0. But after 15 minutes, HCC and MCC Y group show improvement to 1.5. But AI groups no improvement. And HCC and MCC show lower percentage of missed ball on the initial serve. So this demonstrates that organoid intelligence is superior to artificial intelligence in learning efficiency with faster improvement and better performance over time.
So far, my name is Hyojun Lee, who is studying electrical engineering and who is charging of presenting OI for treatment and prospect. Now go on. So far, he has presented the OI for as biocomputing. Now I move on to the next point. The advancement in OI research has significantly increased the potential for developing effective treatments for Alzheimer's disease, while also addressing ethical issues associated with animal testing. Now move on to the next slide. This is first, according to Professor Smilova, Johns Hopkins University School of Medicine, a recent study shows that organoid intelligence, which utilizes human stem cell-derived brain organoids, can replicate critical molecular and cellular aspects of learning and memory in vitro. This provides a promising model for studying Alzheimer's disease. Next page. And they also insist that this initiative approaches enables researchers to explore the process of brain disease, such as Alzheimer's disease, more accurately and develop potential healing strategies without animal model. Therefore, the use of OI not only paved the way for breakthroughs in treating Alzheimer's disease, but also relieves the ethical issues associated with animal testing. And move on to next page. The advancement of OI research has the advancement of OI research, thanks to the advancement of OI research, scientific interest and market size are experiencing significant growth. First, this graph shows the academic interest in organoids and organ-on-chip past the decade. according to organic model developed by deep firm intelligence, the last 10 years witnessed a 15-fold increases in research efforts in both fields. This surge emphasized the impact of OI technology in biotechnology and pharmaceuticals. Move on to next page. Second, the organoid marketing side is also growing rapidly. This graph shows the global organoid market size for 2022 and expected 2030. As you can see from the graph, the market size is expected to expand to $2.51 billion and to $12.21 billion by 2030.
30 seconds.
Okay. In conclusion, why driving increases in both global market size and scientific interest. Now move on to final conclusion.
In summary, we have explored how OI is more energy efficient and required less energy compared to AI, and how important the research process is. And finally, we know that OI market size is growing up. Thanks for your attention, and the floor is now open for your questions.